Good afternoon, everyone. We have our next session, and let's welcome back Joakim Kennedy, who's going to speak about who's calling the 80s to get their finger back, LOL, with old TCP services. Welcome.
Thank you, everyone. So my name is Joakim Kennedy. I'm a senior principal security researcher, and I work for a company called Anomaly. And I'm part of a team that's focused on threat intelligence. So we research and gather threat intelligence and provide that to our customers. So the agenda for today is first we're going to go over and look at what does it mean to live off the land and what sort of shells are. And then we're going to take a trip back to 1982 and look into some tools from the back then. And then we're going to take a look at how we can use a technology from 1977 and how that can be misused in 2019, and maybe some mitigations. So the motivation behind this, the idea behind this presentation sort of came from after seeing a presentation from last year from Patrick Wardle. It's focusing on how to build a firewall and then break it from macOS. And in that talk, he sort of presented one way of getting around this was to use, for example, binaries provided by the operating system. And the sort of this example he gave was Whois. With sort of Whois, you can actually do some data exfiltration, and because the binary is signed by Apple, the firewall sort of trusted the binary. So after seeing that, I wanted to look into what other ways can you actually sort of use these tools to get reverse shells on. And the way, sort of how I wanted to restrict my research was to I wanted to make sure that I'm using binaries that are coming with the operating system, and they are the ones that should open up the socket and do the network part. And the only thing that I'm doing is basically sending and sort of receiving by interacting with this binary. So no sort of writing my own implementation of the protocol, etc. So living off the land. It's more of a sort of terminology that's sort of coming from the land of Windows. The idea is to sort of use what's provided by the operating system. And for example, you can use like WMI or like scheduled tasks or just sort of the net command to sort of move around in the environment. And when you're sort of looking at a Unix system, this technique is kind of much easier. Most Unix systems provide a pretty functional shell by default, and it's very powerful. And so why might you want to do this? And it's not just for the fun, but it may also be a way of sort of bypassing application whitelisting. The other way could be to be more stealthy, using binaries that already exist, and they kind of do what they were designed to do. Other case, it could be that this is sort of like a last resort of what you can use to sort of whatever needs to be done, if it is to exfiltrate data or to download other parts of malwares and stuff. So in terms of shells and backdoors, there are essentially two different kinds. The first one is what we call like a bind shell or a passive implant. And this is more what you're familiar with in terms of like a telnet server or an SSH server. They listen on a port and waiting for connections to connect and then sort of provide the shell. Where a reverse shell or an active implant is sort of constantly beaconing out to a command and control server or another sort of service, and once that connection has been established, then sort of the shell environment can be provided. So there are multiple ways this can be done in sort of simple sort of one-liner script. The most classic one is to use netcat, where you tell basically NetApp just to open up a socket to a host and its port, and then sort of forward input and output to a given binary. Can also do this with, for example, Python. There are pretty much any programming language you can do this. These do require, obviously, the tools to be installed on the host. So that's sort of like where the restriction comes down. And even if you didn't know, Bash on its own can actually open up TCP sockets. So you can actually open up by using sort of this kind of command. This will open up a TCP socket to the prescribed host and the port, and then redirect a standard in and standard out to Bash, essentially. You can actually disable this. It is on by default. So if you want a hardening Bash, this might be a good sort of configuration flag to provide when you're compiling it to disable this functionality. Older versions, I think prior to 4.0, does not include it on by default. So if you get on an older box, it may not have it. So let's introduce Whois. So Whois is a TCP-based, transaction-oriented sort of a query response protocol. It's pretty old. The latest RFC is R3912. So this is a while back. And it was initially sort of designed as a white pages service to provide information about the registered domain. Mainly what's important that needs to be included is the name server that's used. It listens by default on port 43. So the protocol is very, very simple. The client opens up a TCP socket by a SYN, and the server replies with a SYNAC. And then the client sends a query. This query has to end with a carriage return and a line feed. And once the server sees that, it will send back data. And each line will end with a carriage return line feed. And there's no limit on how much can be returned. And the way the server is signaling that it's end of transmission is by closing the socket. Which is kind of problematic if you want to try to do this in a reverse shell, because every time you send a command down, you have to close the socket. And the client will not have the socket back to send the reply back. So you have to kind of work around that a little bit. So let's sort of take a look at a demo of how we can use Whois. So just to walk through, so what we have on left over here is just a TCP dump. So we can just display packets being sent. Down to the right is just a simple netcat server that's listening, and then we're just going to use Whois to send sort of data. The way you can do this on a command line is you just provide it with 2 dashes, and then anything after will be sent as the query. So you can see it return back on the server side, and the server can reply, and at this point, sorry about that, right after the server has sent, you have to close the socket to tell the client that this is the end of the message. So if I send right there, the client is still sort of waiting for more response and until you actually send the FIN packets. Now, the way to sort of get a reverse shell using this technique is kind of have to wrap it around a little bit. So here's the initial sort of information, similar from the Hello World demo. So first, just creating a simple variable. And then I'm kicking off a infinite loop. And here we have some just basic nested calls. So we do this initial call that will send the value of the variable, and then the output for that is then evaluated, and then that is assigned to the variable, and then looped back again. So we're doing that. We kind of get a shell type terminal. We can type anything we want, and it will reply back. We can list folders, essentially. Kind of have a reverse shell using Whois. So using kind of this approach, the problem on the server side is that we always have to sort of close the socket, which is not that sort of user-friendly from a user's perspective. It's easy to sort of work around. You can write a simple sort of server that essentially would read in and read the response from the client, print it out, and then once it finds at the end that it doesn't get anything more, you can read from the standard in, send it to the socket, and then close it, and then just loop back and wait for the client to come back again. So here's a simple little demo on approaching that. So similar setup in this way. We get sort of at the terminal again, and we simply just commands, and I don't have to sort of worry about closing any sockets, and it just straight up just prints out stuff out. So let's go back to 1977. So Finger is it's an older protocol, and it's kind of like Who, if you're familiar with that, but for remote. So it was sort of designed as a way of querying systems to see who is on the system. And then you can also query a Finger server with a specific username. And a user can essentially return a message or have like a default message. These are sort of screenshots from the RFC. And people would put their office location, their office hours, and stuff like that. So it's a way of figuring out where people were and how to get a hold of them. The protocol is sort of similar to Whois. It uses port 79 by default. It's also the same kind of query response type, using the same end-line characters sequence. And the server has to close the socket. So kind of the same problem again. And it apparently also has a sort of if you want to add Finger server to your vending machine, there's a specification in the RFC for that. Make sure it shouldn't eat any money, so be cautious on that. So this is slightly different. So we have top left, TCP dump. And then on the bottom, we're just going to set up it's just a netcat server. And if you may not have been aware, but Finger comes pre-installed by Windows since Windows XP. So what we have on the top right is just a netstat output. They're just cycling through every second, and just to show what is causing, what's open sockets on the machine. And in the bottom right, we have the sort of a one-line bash or one-line reverse shell over. So if you run, you can see in the top it's saying that Fingers open up a socket, and we can sort of retrieve each message line by line from the server. And I can sort of list the C drive just to show that kind of work. And just to prove that it's sort of running on that, you can get calc to pop on the Windows machine. So the way this is sort of implemented from Windows side, it's similar in a way. It's two nested for loops that executes Finger, and then from the output on that, evaluate it, and then each line basically is open up a new socket to send it back. The Unix system version is a little bit simpler, very similar to the Whois. There's a few quirks to it. So Finger puts out a status message the first 2 lines before that. So you can bypass that by using grep and some sed that would sort of put a character for recognition where your command starts, and then just strip it out before you execute it. You can also sort of take in this stuff, can sort of use it as a downloader for example, macros. So you can imagine this sort of being popped into a Word file, and this is just a sort of a POC downloader. It's pretty much copied verbatim from the previous slide, just a few quirks to handle how strings is handled in VBA. And if you run, so this is just a macro that will execute once you open up Word. And if you check that in VirusTotal, when I first put this up, it was about 10% detection rate. So to the vendors that actually did detect it, thumbs up. So someone thought ahead of it, which is great. So from a sort of blue team's perspective, how do we sort of mitigate this kind of scenarios? They are using some standards on default ports, and particularly Finger on Windows do not have a flag to sort of tell the client to use another port. So you can, if you don't need port 79 to go outside your perimeter, block it. You should definitely do some command line logging. There's definitely some anomaly in type of how the command line is structured that should be able to be picked up. And you can also look at on the network traffic, if you're seeing a bunch of Whois requests going out or Finger requests, there may be something strange going on. There's also a lot of other strange activity, especially the one with Finger. Each time it sends the response back for each line, it does execute the binary again. So you have a lot of new processes spawned. To sort of conclude with this, sort of the lessons learned, Unix tools, no matter how old they are, you can sort of find them anywhere. I think one good lesson learned is also if a service can sort of do a network request, there's definitely a way you can misuse this for something that it's not intended to do. So in general, I would say mitigating against living off the land is not an easy task, and hopefully we can improve on that. Thank you, everybody, and I can take questions if you have any.
We have like 10 minutes for questions, so.
Mike, go over there.
I have to laugh. A lot of the rules I see, especially up in AWS for instances like security groups, nobody blocks outgoing. It's like wide open. But I have seen in the past DNS used for control channels and RADs, and I was just curious if you've got any thoughts on that.
So there's definitely a lot of stuff you can do with DNS. I didn't want to go with that route because it's already been done a bunch. I wanted to look into something new. Obviously DNS is hard in a way because it's hard to block. And the requests are not, it's basically relayed to where you need it. So it has sort of that benefit over this kind of a technique. So yeah, I mean, I've seen it, I've come across it a lot. But But that's kind of why I didn't go into that approach.
Any other questions?
Thank you. Besides Finger and Whois, are there any other older tools you've been looking at?
There's a couple of them. Trying to remember which one I've looked at. It's just escaped me, I'm sorry. But yeah, I mean, the slide is, if you can do an outbound connection and there's a way of squeezing information in and it will come back with what the server replies, you can, in theory, use it. It's all about how you manipulating the stuff that comes back. In general, it's easier on Unix because you have more shell tools to do it. Writing command line, like a reverse shell in Windows command line, is not straightforward. Looks very, very weird because you can't assign stuff to variables in an easy way and things like that. So I think you could now. I think you can do it with LDAP. As one other tool. So.
No more questions?
Actually, that brings to mind, what about, what comes to mind is Ike, for example. Is there any way to piggyback on that, maybe? Have you looked at that? Or anything similar to that? I mean, like these encrypted protocols, or some of them leak, I know. Yeah,
so I didn't look into it, but that could be. It's all about, if I can control what I can send, and then it gets back into a parsable way for the client. So that's really the limitation. So if you find another binary, just try it and see. I mean, there's a couple of examples of how to do it. I know there's a project that's hosted on GitHub that is listing off a bunch of binaries you can use for exfiltrations and stuff like that. A bunch of them do not give you a response back, which is problematic because you're missing that half, but you can definitely upload stuff. Same with like download.
There's a question online for the audience, actually. Can we get hands for who is logging processes, execution, and command line? That's a good question. A few hands. Couple. Good. Yeah, logging command line logs. If you guys don't have any more questions, thank you, Joakim, for your presentation.